When troubleshooting a tripping ground fault interrupter, GFI, circuit breaker, a systematic approach is essential for accurately identifying the source of the problem. The initial steps taken to isolate the issue were logical and well executed. However, before definitively concluding that the GFI circuit breaker is faulty, consider these additional troubleshooting steps. Firstly, check the GFI outlet. If a GFI outlet is present in the circuit, verify that it is functioning correctly. Test the outlet by pressing the test button, which should trip the outlet. If the outlet does not trip, or if the reset button does not engage properly, the GFI outlet itself may be the cause of the problem. Replace the GFI outlet if necessary, and then retest the circuit. Secondly, test the wire connections. Use a multimeter to check the continuity and resistance of the wire connections throughout the circuit. Ensure that all connections are tight and free of corrosion. Loose or corroded connections can create resistance, which can lead to overheating and nuisance tripping of the GFI circuit breaker. Pay close attention to the connections at the circuit breaker, the GFI outlet, the hand dryer, and any junction boxes in the circuit. Thirdly, look for loose connections. Examine the entire circuit for any loose wire nuts or terminals. Loose connections can cause intermittent faults, which may not be immediately apparent. Carefully tighten all wire nuts and terminals and ensure that the wires are securely fastened. After completing these additional troubleshooting steps, if the GFI circuit breaker continues to trip, it is highly likely that the breaker itself is defective. GFI circuit breakers are susceptible to failure over time, and internal components can degrade, leading to nuisance tripping. Replacing the GFI circuit breaker is a reasonable solution to resolve the tripping issue. When replacing the GFI circuit breaker, be sure to use a new one of the same amperage and type. Using a breaker with a different amperage rating can create a safety hazard and may not provide adequate protection for the circuit. Also, ensure that the new breaker is specifically designed for GFI protection. After replacing the GFI circuit breaker, reconnect the hot and neutral wires to the hand dryer and test the circuit to ensure proper operation. Turn on the hand dryer and observe its performance. Use a multimeter to measure the voltage and current in the circuit and verify that they are within the specified ranges. Monitor the circuit over time to ensure the problem has been resolved. Keep a close eye on the circuit breaker and the hand dryer for any signs of overheating or malfunction. If the GFI circuit breaker trips again, further investigation may be necessary to identify any underlying issues. In some cases, the problem may not be with the circuit itself, but with the load that is connected to it. For example, a faulty hand dryer could be drawing excessive current or creating a ground fault, which could cause the GFI circuit breaker to trip. If you suspect that the hand dryer is the problem, disconnect it from the circuit and test it separately. Use a multimeter to measure the resistance between the hot and neutral wires, as well as between the hot and ground wires. If the resistance is low, there may be a short circuit or ground fault in the hand dryer. In this case, the hand dryer should be repaired or replaced. In addition to the steps outlined above, there are a few other factors to consider when troubleshooting a tripping GFI circuit breaker. One factor is the age of the wiring in the circuit. Over time, wiring can deteriorate, which can lead to insulation breakdown in ground faults. If the wiring in the circuit is old or damaged, it may be necessary to replace it. Another factor to consider is the presence of moisture in the circuit. Moisture can create a conductive path between the hot and ground wires, which can cause the GFI circuit breaker to trip. If you suspect that moisture is a problem, inspect the circuit for any signs of water damage. Dry out any wet areas and seal any leaks to prevent further moisture intrusion. Finally, it is important to follow all applicable electrical codes and safety regulations when working with electrical circuits. Always turn off the power to the circuit before beginning any work, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electrical circuits, it is best to call a qualified electrician for assistance. Understanding the purpose and function of a GFI circuit breaker is crucial for effective troubleshooting. A GFI circuit breaker is designed to protect people from electrical shock by detecting ground faults. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. GFI circuit breakers work by monitoring the current flowing through the hot and neutral wires in a circuit. If the current flowing through the hot wire is not equal to the current flowing through the neutral wire, it means that some of the current is leaking to ground. When a GFI circuit breaker detects a ground fault, it quickly trips the circuit, cutting off the flow of electricity and preventing electrical shock. GFI circuit breakers are required in many areas of a home or building, such as bathrooms, kitchens, and outdoor locations, where there is a high risk of exposure to water. They are also commonly used in construction sites and other industrial settings. When troubleshooting a tripping GFI circuit breaker, it is important to understand that the breaker is doing its job by detecting a ground fault. The goal of troubleshooting is to identify the source of the ground fault and correct it. Simply replacing the GFI circuit breaker without addressing the underlying problem will not solve the issue and may create a safety hazard. There are several common causes of ground faults that can trigger a GFI circuit breaker. These include faulty appliances, damaged wiring, and moisture intrusion. Faulty appliances can create a ground fault if there is a short circuit or insulation breakdown within the appliance. Damaged wiring can also create a ground fault if the insulation is worn or cracked, exposing the bare wires. Moisture intrusion can create a conductive path between the hot and ground wires, which can cause the GFI circuit breaker to trip. To effectively troubleshoot a tripping GFI circuit breaker, it is important to have a good understanding of electrical circuits and wiring practices. This includes knowledge of basic electrical concepts such as voltage, current, resistance, and grounding. It also includes knowledge of electrical codes and safety regulations. In addition to a multimeter, there are several other tools that can be helpful for troubleshooting electrical circuits. These include a circuit tracer, which can be used to identify the path of a circuit, and a ground fault locator, which can be used to pinpoint the location of a ground fault. A circuit tracer works by injecting a signal into the circuit and then using a receiver to trace the signal along the wires. This can be helpful for identifying the path of a circuit that is hidden behind walls or in ceilings. A ground fault locator works by measuring the current flowing through the ground wire. If there is a ground fault, the ground fault locator will detect a current flowing through the ground wire and will indicate the location of the fault. When using electrical tools, it is important to follow all safety precautions. Always turn off the power to the circuit before beginning any work, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electrical circuits, it is best to call a qualified electrician for assistance. In summary, troubleshooting a tripping GFI circuit breaker requires a systematic approach, a good understanding of electrical circuits, and the proper tools. By following the steps outlined above, you can effectively identify the source of the problem and correct it, ensuring the safety of yourself and others. Always prioritize safety when working with electricity, and never hesitate to call a qualified electrician for assistance if you are unsure about any aspect of the troubleshooting process. Furthermore, remember to consult the 2017 National Electrical Code (NEC) for specific requirements and guidelines related to electrical installations and safety. The NEC provides detailed information on topics such as wiring methods, grounding, overcurrent protection, and GFI protection. Familiarizing yourself with the NEC can help you to ensure that your electrical work is safe and compliant with industry standards. For example, NEC Section 210.8 specifies the requirements for GFI protection in dwelling units. This section requires GFI protection for receptacles located in bathrooms, kitchens, garages, and outdoor locations. It also requires GFI protection for certain appliances, such as dishwashers and washing machines. NEC Section 250 provides detailed information on grounding and bonding requirements. This section specifies the requirements for grounding electrodes, grounding conductors, and bonding jumpers. Proper grounding and bonding are essential for preventing electrical shock and ensuring the safe operation of electrical equipment. NEC Section 310.15 provides information on ampacity ratings for conductors. This section specifies the maximum current that a conductor can carry safely based on its size, insulation type, and installation conditions. It is important to select conductors with adequate ampacity ratings to prevent overheating and fire hazards. NEC Section 406.4 specifies the requirements for receptacles. This section covers topics such as receptacle types, mounting requirements, and GFI protection. It is important to install receptacles correctly to ensure their safe and reliable operation. By consulting the NEC and other relevant resources, you can gain a deeper understanding of electrical systems and improve your troubleshooting skills. Always remember that safety is paramount when working with electricity, and never hesitate to seek professional assistance if you are unsure about any aspect of the electrical work. Before touching any electrical components, use a non-contact voltage tester to verify that the power is off. These testers can detect the presence of voltage without requiring direct contact with the wires, providing an extra layer of safety. If the non-contact voltage tester indicates the voltage is present, double-check that the circuit breaker is indeed turned off and that there are no other sources of power feeding the circuit. Once you are certain that the power is off, you can begin your troubleshooting process. Remember to use insulated tools to further protect yourself from electrical shock. Insulated tools have a protective coating on the handles that prevents electricity from flowing through them to your body. When working with wires, be careful not to damage the insulation. Damaged insulation can create a ground fault or short circuit, which can cause the GFI circuit breaker to trip. If you accidentally damage the insulation on a wire, repair it immediately with electrical tape or replace the wire. When connecting wires, make sure that the connections are tight and secure. Loose connections can cause resistance, which can lead to overheating and nuisance tripping of the GFI circuit breaker. Use wire connectors that are appropriate for the size and type of wires you are connecting. When working in damp or wet locations, take extra precautions to avoid electrical shock. Wear rubber gloves and boots to insulate yourself from the ground. Avoid touching any metal objects that could be grounded, such as pipes or appliances. If you are unsure about any aspect of the electrical work, it is always best to call a qualified electrician for assistance. A qualified electrician has the training and experience to safely and effectively troubleshoot electrical problems. They can also identify potential hazards that you may not be aware of. Replacing a GFI circuit breaker can be a straightforward task, but it is important to follow the proper procedures to ensure your safety and the proper functioning of the circuit. Firstly, turn off the power to the circuit at the main electrical panel. Secondly, remove the cover plate from the circuit breaker panel. Thirdly, locate the GFI circuit breaker that you want to replace. Fourthly, use a screwdriver to loosen the screws that hold the wires to the circuit breaker. Fifthly, carefully remove the wires from the circuit breaker. Sixthly, remove the circuit breaker from the panel. Seventhly, install the new GFI circuit breaker in the panel. Eighthly, reconnect the wires to the circuit breaker, making sure that they are securely fastened. Ninthly, replace the cover plate on the circuit breaker panel. Finally, turn on the power to the circuit at the main electrical panel. After replacing the GFI circuit breaker, test it to make sure that it is working properly. Press the test button on the circuit breaker. The circuit breaker should trip, cutting off the power to the circuit. Reset the circuit breaker by moving the handle to the off position and then back to the on position. If the circuit breaker does not trip when you press the test button, or if it does not reset properly, there may be a problem with the circuit breaker or the wiring. Call a qualified electrician for assistance. When selecting a replacement GFI circuit breaker, make sure that it has the same amperage rating and type as the original circuit breaker. The amperage rating is the maximum amount of current that the circuit breaker can safely carry. The type of circuit breaker refers to its interrupting capacity, which is the maximum amount of current that the circuit breaker can safely interrupt in the event of a fault. Using a circuit breaker with the wrong amperage rating or type can create a safety hazard. If you are not sure which type of circuit breaker to use, consult a qualified electrician.